Anna has $2,000 available to invest at 12% per year, compounded annually. She'll need the money in 6 to 8 years to finance her children's education. Use a graphing calculator and graph A. Okay, so we've got the function and we're not seeing it. We have to adjust the window. We can tell that the vertical A value is going to start at 2000. So we have to change our window. So that at least goes to 2000. So I'll make it 4000 just for extra room. And we're only interested in positive n values. So here's a graph, and this shows the $2,000 growing by 12% each year. Okay, so using the TBM solver now, how much money would she have after 6 or 7 or 8 years? So if we want 6 years, we're going to set n to 6. Interest rate is 12%. The amount of money that we're investing is $2,000. It's negative because we are taking it out of our wallet and putting it into the bank. And we want the future value or amount. So we get $3,900 and change. Let's see how this agrees with our graph. So after 6 years, we have that amount. So you can see that those two numbers agree. We could do the same for 7 years with one adjustment, and then we resolve for the future value. And we can see that it's going up. And that makes sense, because if you invest your money for longer, you should have a higher amount. We go for 8 years. So looking at the graph, we can see that the longer we invest it, the more we're going to have. We can also see that the graph is curving upwards. It's getting steeper and steeper. So with each year that goes by, we're getting more and more added on to our initial investment. This is the beauty of compound interest. Tyler wants to have $5,000 in 4 years' time. How much would Tyler need to invest today at 4% per year compounded quarterly, or at 4.5% per year compounded quarterly? So the TVM solver will give us an answer very quickly. We're going to put in 4 years, 4.5%. The present value is what we're looking for because we want to know how much to put in today. In the future, we want to have the $5,000, take it out of the bank, put it into our wallet, and therefore it's positive. The compounding periods per year is going to be 4 times per year because we're doing it quarterly. So every quarter year, we are compounding the money. In other words, 4 times per year. So now we can, the only thing that's left to do is to solve for the present value or principal. Oh, I'm going to do 4% first. And if we change that to 4.5%, if we're getting a higher interest rate, we would expect that we don't need to invest as much money to get that $5,000. And we can see that that's true when we solve using 4.5%. So we've done this using the TVM solver. We could do it using a spreadsheet like we did before. I will do it on paper. So what we're looking for is the principal, and we're going to divide that by 1 plus the interest rate. And because we're compounding it quarterly, we have to divide it by 4. So quarterly for 4 years means 16 compounding periods. So the exponent is going to be 4 times 4, or 16. Using your calculator, I can type all of this in and calculate it in one step.